going to see the important topic, free body diagram. In practice, a problem in engineering mechanics is derived from an actual physical situation. A sketch showing the physical condition of the problem is known as the space diagram. So a large number of problems involving actual structures, however, can be reduced to a problem concerning the equilibrium of a particle. This is done by choosing a significant particle and drawing a separate diagram showing this particle and all the forces acting on it. Such a diagram is called as a free body diagram. So in this given condition, this truck here is going to be loaded by a crate. Now if you notice, there are two people who are pulling strings to hold the crate in that particular given position. Let us assume that in this current situation, crate and the ropes are in equilibrium. So in this condition, point A becomes the point of significance. So let us see the same problem here. The free body diagram is shown in the right hand side. If you see carefully, I have marked the tension in the rope AB as TAB, the tension in the rope AC as TAC, and the weight of the crate is, in this condition, it is given as 736 Newton, and the angles between the forces are also known. Since this is having only 3 forces, I can easily go for my sine law, and this triangle can be easily used for solving such kind of problem. So with that, let us try solving this problem. A chairlift has been stopped in the position shown. Knowing that each chair weighs 250 Newton and that the skier in the chair E weighs 765 Newton, draw the free body diagram needed to determine the weight of the skier in the chair F. Point C is my point of interest. So let me mark the point C. For this condition, let us consider the tension in the ropes in these two directions. And I have the weight of the skier acting vertically downwards. And in this condition, it is mentioned that each chair is weighing 250 newtons and the weight of the skier in chair E is given as 765 Newton. So let us assume that the weight of the skier sitting in this chair F is not known. So this will be W, that is the weight of the skier, plus 250 Newtons. I do not know the force acting or the tension acting along the rope CD. So I'll just mark it as TCD, and I definitely do not know the force acting along the CB, so I will mark that as TCB. Yes, I can definitely find the angle from the given figure and then fill up these angles as well, because they are given here directly and they are given here based on the length. So if you look at the stretch BC, it is 24 meters in the x direction, 10 meters in the y direction. So from that I can definitely find out the angle. So let us draw that triangle here. This point is B, this point is C, and let me name this point as P. Okay, now this length is given to be 24 meters and this length is given to be 10 meters. So all I have to find is this angle here. To find that angle, you have to just put tan inverse of opposite side by adjacent side, that is 10 divided by 24. which is equal to 22.6 degrees. Now coming to the other angle that I have to find. For that, I'll construct another triangle here. This point is known to be C and this point is known to be D, and let me name this point as Q. So this length here is given to be 6 meters according to the figure, and this length here is known to be 1.1 meters. So I have to find out this angle here. So to find out that angle, I just have to find tan inverse of opposite side by adjacent side. 1.1 divided by 6, which is equal to 10.38 degrees. So I have all my values required. This is 22.6 degrees. So this will be 22.6 degrees, and this angle is known to be 10.38 degrees. So with these, all the data which are required for drawing the free body diagram is obtained. Now all that I have to do is draw the free body diagram with the corresponding angles and the unknown forces represented with proper representations. So here I can say this force TCB is acting like this, this force TCD is acting like this, and I have a weight plus 250 Newton acting like this. Okay, now I just have to find out this angle, and this angle separately. This angle will be 180 minus 22.6 plus 10.38, so which will roughly come out to be 167.7 degrees. This is 90 plus 22.6, so that will be 112.6 degrees, and this will be 90 minus 10.38, which will be 79.7 degrees. So totally you will find this to be 360 degrees. This is how you are supposed to draw the free body diagram of any point of interest to solve the problem. The important things that you have to be careful about while drawing a free body diagram is that in the solution of a problem involving the equilibrium of a particle, the diagram shows the particle and all the forces acting on it. And please indicate in your free body diagram the magnitudes of the known forces as well as the angle or dimensions that define the direction of a force. Any unknown magnitude or angle should be denoted by an appropriate symbol. Nothing else should be included in the free body diagram. Drawing a clear and accurate free body diagram is a must in the solution of any equilibrium problem. Skipping this would save you some pencil and paper, but it's very likely that you will make a mistake. So free body diagram for any equilibrium problem is essential. So I guess in today's lecture you would have understood what is the significance of a free body diagram. Please do give your feedbacks in the form of comments. It will be really helpful for me to improve the coming lectures. Thank you. Meet again soon.